Hello there and welcome to A2 Maths from June 2018, paper 1, and here we're looking at question 12, exponentials log-based question. So the value v of a vintage car in t years after it was first valued on the 1st of January 2001 is modelled by the equation v equals a p to the power of t, where a and p are constants. Given that the value of the car was 32,000 on the 1st of January 2005 and 50,000 on the 1st of January 2012, part AI is find p to 4 decimal places. Okay, so 2001 we'll call effectively year 0. So 2002 would be year 1, 2003 would be year 2, 2004 would be year 3, and 2005 would be year 4. So when t equals 4, the value is equal to 32,000. And we can kind of spot the pattern there that when t is 11, the value is going to equal 50,000. So let's now plug this into the model. We have 32,000 equals a times p to the power of 4, and we have 50,000 equals a times p to the power of 11. Now what I can do is I can use these as simultaneous equations, and I can do equation 2 divided by equation 1. So that's going to give me 50,000 over 32,000 equals ap to the 11 over ap to the 4. We can see here that the a's will cancel out, and using our rules of indices we get p to the 7. So what we're now going to do is p is the 7th root of 50,000 over 32,000, and we therefore get that p to 4 decimal places is 1.0658. There we are, so that's the answer to part I. Show that the value of a is approximately 24,800. Well, if I now plug this back into equation 1, 32,000 equals a times by 1.0658 to the power of 4, and divide that onto the other side, I get a is equal to 24,805, which is basically 24,800, isn't it? So there we are, that's the answer to part A. Moving on now to part B, let's just write down what we had before. We have v equals 24,800 times 1.0658 to the power of t. With reference to the model interprets the value of the constant a. Well, a, 24,800, is the value of the vintage car. The vintage car on the 1st of Jan 2001, when t equals 0 basically, and find the value of the constant p. P is the proportion of the value, proportional change, in the value of the car each year. Or in other words, there's a 6.58% increase. So there we are, that's the answer to part B then. Now moving on to part C, just a reminder of what we had before. 24,800 times 1.0658 to the power of t. Using this model, find the year during which the car first exceeds 100,000. Okay, so we're looking for 24,800 times 1.0658 to the power of t to be bigger than 100,000. Okay, so the first thing we'll do then is we'll divide by 24,800, so 100,000 divided by 24800, and we get 1.0658 to the power of t is greater than as a decimal, 4.03226, basically. That carries on and on and on. Right, now what we need to do is we now need to take logs. We need to work out what the power is on this thing, so we're going to need to do log of base 1.0658, and then in the brackets needs to go the answer to the value before. So using logs 1.0658, then it's of answer button, so that's going to be greater than 21.88. So that means it's going to be in the 22nd year. So that means it's going to be in, if it's in the 22nd year, then that's going to be in 2022, because it's going to be towards the end of 2022 that the car is going to be worth over 100,000. So there we are. That's the answer to this question then. That's 10 marks for question 12 then. Let's move on to question 13.